So yesterday we went over some of the basics and the fundamentals of basic AutoCAD and the Civil 3D user interface. We talked about workspaces and setting up your support files, model space versus paper space. Talked about templates and layers, and went over some of our already existing training documents in terms of CAD natives and things like that. We worked a bit with XREFs and talked a bit about data management, and so we sort of ended with the idea that we talked today about printing. But today we're gonna actually go back to a task that we started yesterday, which was breaking apart a survey, which not everyone gets involved with here, but everyone should know what it takes. And we're going to build on that task of breaking apart the survey, and then move into discussions of color use. And how that impacts how things look on our final prints. So we will be building towards printing today, and even probably have some discussion of the sheet set manager and some other things like that, and then also covering topics on Civil 3D objects like points and alignments, surfaces, and profile and section views. So if we remember yesterday, we looked at this survey and discussed how to break it apart, or at least get the contour data out to create a surface. So we're going to repeat that task today with an emphasis on data management. And then when we get to the 2D line work XREF portion, we'll be talking a lot about colors and layers. So without further ado, let's go ahead and get started. So as you can see, I have both my tool space open. We're set to the settings tab. I'll put it back on the prospector tab, and my properties palette. Properties palette I leave open almost all the time, and it's a powerful tool to keep open, and it gives you a lot of information. The first thing we're going to do here is isolate the contours and then bring them into one of our Civil 3D templates. So I'll first click on one of these to first verify that it's a polyline and not some other type of object. Here it's giving us the information that it's a 2D polyline. That's fine. We just want to verify that it's at a proper elevation based on the properties within the elevation property. And I'll check a major contour as well, and check that it's at elevation as well. And so what we'll do is we'll grab a minor and a major contour, and then right click to select similar, and be sure that we've grabbed all the contours throughout the site on this survey, and nothing, say over here in the legend that we wouldn't want to carry over to make a surface out of. So now that I have all of the contours for the surface, I'll just right click, go to clipboard, and copy. Once that's copied over to the clipboard, I can open up I'll go and open up a fresh Civil 3D drawing template. We know we're in the right template because it opens up the paper space. And once it's loaded, we'll switch over to model space and paste these contours into our model space. Again, guys, if you have any questions while I'm presenting, please don't hesitate to chime in, either through chat or here in the office. All right. In model space, right-click, clipboard, paste original coordinates. And now we have this the surface data isolated from the 2D line work of the survey. And so from here, you can go ahead and select all of your contours. If you're fairly certain they're all at elevation and everything's looking good, you can go and select them before you create your surface, and then create your surface. Again, since we're using our template, this is going to show up on its own unique layer here. It's important that we give everything a proper name. So all caps in this case, EG. And we'll change the style of this eventual surface to 1 foot and 5 foot existing, and hit OK, and then OK again. Now we'll expand surfaces under our prospector, and then expand the definition for EG. And then since we already have those contours selected, I'll right click on the contour section of the definition of the surface and hit Add. I'm going to go with all the defaults on this page and hit OK. What we get is a pretty representative surface based on that contour data. And what I'm going to do here is just refine the extents of our eventual surface based on the contour data. And to do that, I'm going to send it to the back so that I can see the sort of ghost of those of the contours, the extent of those contours here and here. Now what I'm going to do next, guys, is this green line that we have is a surface boundary. It's based on the style. If we were to go and look at the surface style, we could see that it has a border on the C10 BNDY boundary layer, and everything's set to bilayer, bilayer. And that part of the surface is turned on in the display of that style. It's also telling us that we have major contours on their own layer, minor contours on their own layer. Those three are the only three objects that are turned on in this surface style, and that's by intent. So what I want to do now is click on this surface and extract the boundary. Now this ribbon, you'll notice at the top of the screen, is context sensitive. So when I select the surface, we get surface editing tools pop up as soon as I click on the surface. And one of those options is up here. It's called extract from surface. And if I click on this drop down, we'll see that there's a number of options here. This has changed from previous versions. If you were using 2014 or 2015, these had separate options under this drop down. So just be careful when going in here that you don't accidentally select an option that you don't intend. So the option we want here is to extract objects, and then we get a dialog box asking what type of objects we want to extract. Now we already have the data for the major and minor contours, so we don't need to extract that. If you wanted to, on an existing surface that say is data shortcutted into your drawing, if you wanted to extract a single contour, then you would uncheck the others and then go to select from drawing and then go and select that individual contour individually. But the data that we really need to pull out right now is just the border. So we're going to uncheck everything but the border and then extract that from the drawing. So what that ends up creating is a 3D polyline. If we look at our properties palette over here, we see that it's a 3D polyline, and it's on the C10 boundary layer. We investigate that layer. I'll go ahead and make it current. This button here to the right of the layers drop down means it tells you to make that object current. So any object that you select and click this button, that will become the current layer in your drawing. It's an easy way to investigate layer properties is to go and make that current, and then when you go back over here to hover on your layer manager, it'll be highlighted and show you the information you need. What I wanted to point out by doing this, guys, is that all of the properties for this layer, the color, the line type, and everything is associated to the layer as it should be, and that this layer itself is a non-plot layer. Okay. So no matter what we do to this line, unless we change its layer data, it's not going to change the look of the drawing, except for in a minute when we trim the surface to the new to the new boundary based on the edges of these contours. So with a 3D polyline, it's a perfectly valid object type to use as a surface boundary. It's the native boundary type that's used when you create surfaces from contours. That 3D polyline can be converted to a 2D polyline fairly easily, and that takes place in the grading dropdown. It's not necessary to do what we're doing next, but I just wanted to show you how that works so that you can go back and forth between 3D and 2D polylines. And just so you understand the difference between 3D and 2D polylines, I want to isolate this 3D polyline very briefly just to show you what it's doing. So I'm going to go here into this object viewer, and this is a full screen object viewer. So this 3D polyline, at every vertices, it has a different elevation value. And that's what 3D polylines do, is that they move up and down based on their vertices elevation. And that vertices elevation can be changed through the properties menu. So if we see here, we have looking at current vertex 1, which is sort of arbitrary, but that's where it's putting a white X at that location, where vertices 1 is. It's telling us the elevation of that vertices is 218, and that's simply by nature of the 218 contour ending on that edge of the surface. And so if we were to cycle through these vertices, we would see that each one has a different, not necessarily a different value. We have 219 across the board there, and then we go 218, then we're going to start going down with these other vertices. That's how 3D polylines work. Each vertices has its own designated elevation, which can be altered very easily through the properties menu. To turn a 3D polyline into a 2D polyline, we simply will actually not select it first. We'll go up to the grading dropdown and to polyline utilities, and then click on convert 3D to 2D polylines. And I'll do that, and then select the 3D polyline, and then right click to execute the command. And then when we click on the object again, we see over here it's just a polyline. You may notice that when we use these polylines from the contours that it claimed that they were 2D polylines. This is simply by nature of the surveyor using a separate platform than Civil 3D to create his drawing. He's either using a Carlson survey add-on to AutoCAD or some other add-on which gives us slightly different object types, even though for all intents and purposes a 2D polyline is the exact same as a polyline. What we'll notice here is that while we can cycle through these vertices and look at the data of the vertices, that all of the vertices are at the same elevation now. Polylines by their nature, while they can snake across the page, are really all, no matter what, are all at one elevation. And that's the main difference between a 2D and a 3D polyline. So with this 2D polyline now selected, I'm going to refine the surface. And all I've done here, guys, is hover over a existing vertex. And then as long as I have dynamic input turned on, when I hover over this vertices, I can click on this option to add vertex. Now you'll notice that this vertex is allowing me to add a vertex in one direction only. If I wanted to add a vertex in between this vertex and this vertex, I would not be able to do it by clicking on or hovering over this one and then clicking add vertex. I would actually need to go in this direction. This is based on the direction of the polyline. Even though it's a closed polyline, it has a direction in which it was generated with. And so when adding vertices to polyline, it's important to know what direction your polyline is going in. All you have to do is start with one add vertices to figure out what direction you're going. Now I'm going to have to go back and turn on my O snaps and make sure that I have endpoint selected. And I'm going to go and turn off every other O snap condition except for endpoint. And highlight that to make sure it's on. So now every time I add a vertices, it will automatically snap to the closest endpoint to where I'm going. And what I'm shooting for is the edge of each one of these contours. Basically what's happening here, guys, is that the Civil 3D has the contour data to develop the surface. But because this contour comes up here and then some of the other contours at the far edges come over here, it's actually interpreting what the contours may be doing between those elevations. And that's why we have a boundary that's out here originally that's not perfectly representative of the survey surface. So as we click through here, we'll add vertices at the endpoints of every single contour that we can find. And essentially, we're refining the boundary for this. So here we have a tiny gap. This is a perfect example where AutoCAD's doing the right thing, where Civil 3D is doing the right thing. There's a tiny gap in our contour data, and Civil 3D says, hey, you know what, I'm going to fill that in. And that's fine by us. We would want that to fill in. But when we get down here, we notice that we have our boundary is just up above this contour, which is the elevation 200 contour. But we have contour data from the surveyor that goes all the way down here. What we want to do here is just slightly refine this by adding another vertices just below here so that that boundary line goes above our existing contour data and below where there's no contour data. As we get over to the edge here, we can see that the boundary is doing what it's supposed to for the most part. Over here, we're going to need to, not quite. We're missing a piece of data here. So we are going to need to expand instead of contract this surface boundary out a bit, just beyond that piece of contour data. And then we'll keep going around the surface. Thank goodness this is a small area. This can take a lot of time on bigger surfaces from surveyors. But it's important because we don't want to show fake data. We only want to show what the surveyor has given us and not try to allow AutoCAD to interpret too much in between. All right, we're looking pretty good here, but then once we get down here to the bottom, we're going to need to close this off. And we get here, we can see there may be a need for one more vertices up here just to get above that interpreted line. So once I've made my way around this site and looking at the contour data that we have and seeing if there are any more edge conditions, I can see that there are a few here. And here, this is close enough where I'm not putting a vertices at every end of the contour, but because the angle is so uniform there, I can cut that off without having to put a vertices at every point. All right. We're not done yet. You see there I clicked on, I snapped to inadvertently a separate endpoint. So just be very careful when you're using those snaps that you snap to the intended target. All right, now we have a better defined boundary. And what we're going to do next is apply that boundary to the surface definition. I'll expand this up just a little bit so you can see what we're talking about here. So again, we're looking at surfaces and then our EG surface and then the definitions. We have here a boundary. I'm going to deselect this boundary first and then right click here and click add. We get an options window here whether we want to add an outer, a show boundary, a hide boundary, or a data clip. This is obviously going to be an outer boundary. And we will, the non-destructive break line, we're going to ignore that for now because this is an outer boundary. That may be more pertinent for different types of inner boundaries and whatnot. For now, we're going to go with the non-destructive boundary, hit OK, and then select that polyline. What we see is the surface automatically updates to show or to remit the data outside of our contour data. This is exactly what we want, and now we've got a pretty clean surface to work with. From here, guys, it becomes a data management task. So we extracted the contours from our survey and dropped it into one of our template drawings, the Civil 3D template drawing. And then we refined the edges of that surface so it could be more representative of the actual survey topo. But now we need to save this and make it usable for other people in the company and for ourselves later. We don't really want to be working off of an existing ground surface that has live contours in the data. So the method we're going to be using is saving this to a proper location on our server and then using the data shortcuts folder to both create a shortcut and then import it into a new drawing. So let's go into a save as. And I'd just like to point out that this survey, this is a different project, sorry. But we're going to go to our 2017 Greensboro folder, Tenaska River intake dredging, SC products, CAD. And then I want to point out that the survey itself was saved into archives as received into a dated folder. This is the drawing that's still open called Intake Topo 04-1817 that we extracted the contours out of. So that survey drawing, we will never, ever, ever save that drawing because we want it to be archived exactly as it was received on that date from the surveyor. And we should not be making changes to that drawing. So when we go back in and grab some more data and then close the drawing, we'll never actually save it. But where we're going to be saving this existing ground surface that we've created is going to be into drawings, base drawings, data reference DWG. The data reference DWG folder is where we save all of our data shortcut civil drawings. Now, this can get a little bit confusing because we have basically two separate things going on. We have a data shortcuts folder which is right here. And it's only for storing XML files. And we don't actually create those XML files ourselves. Civil 3D does when we generate a data shortcut. But the XML files are being pulled from the data reference DWG folder. So this is where all the host drawings for your data references, your data shortcuts are pulling from. And so we have a naming convention that we use for all data reference DWGs. For this case, since it's a surface we're saving, we're going to name this all caps surf underscore EG for existing grade. Once the drawing is saved, I'm going to need to go back into my prospector and change my working folder because this is pulling from a project called Carter's Creek, and that's not the current project that I'm working on here. So I'm going to right click on the data shortcuts and go to set working folder. We're going to navigate back to the 2017 Greensboro folder, but to a different project. So here we are at Tenasca River Intake. I will expand SE Products and CAD, and then at this point all I have to do is select Drawings and hit OK. This changes the data shortcuts folder to the current project, and if we expand alignments, because there's a plus sign, then we see that nothing's been added to this data shortcuts folder yet. This is our first task. We've just gotten the survey this week, and we're breaking it up to its component parts. So since this drawing's been saved, I should be able to right click on data shortcuts and say create data shortcut, and we get a pop-up. This will give you a list of every single object that's available to be data shortcutted from this drawing into the data shortcuts folder. In this case, we only have one object that could be referenced, so we'll select EG and then hit OK. We should notice that that surface is now added to our surfaces list under this project. From here, we can close and save this drawing and keep moving.
Did you delete out the polyline surface? Or are they still in that?
They have to. Okay, so the question here from Corey was if I deleted out the contours for, you're asking for the contour polylines? He'd asked if we deleted out the contours for that surface, and the answer is no. So, and the way I'm going to answer it is actually go back into that surface and show you. So these contours are actually part of the definition of that surface. If for any reason you were to change or delete any piece of this surface data, the surface would show that it's out of date and that it would need to be updated. So, for instance, if I were to delete a single contour from this drawing, we would see that we get a big exclamation point and it tells us that the surface is out of date. So that elevation contour, let's see, that would have been elevation 210, is now missing from this point up for that surface definition. And if I were to right click and say, if I were to right click on the surface name and ask it to rebuild, we would see that the surface would rebuild without that data. Now CAD's trying to interpret as best as can where that data should have been, or where that contour should be. But since it doesn't have the contour there, it's not doing quite as good a job as the surveyor did of figuring out where that elevation 210 is. So every piece of this definition is needed to build that surface. Okay, I'm going to close this without saving because we made a change that we don't want to hold on to. Okay.
Thanks.
Yes, ma'am.
Do you have to change the boundary line back to boundary so it won't print, or do you keep it?
No, it stayed on the C10 boundary layer. If we wanted to show up, we would have to make a change in the style of the surface as opposed to changing that particular contour. So that contour, not contour, but that boundary that we added is part of the surface definition, but is still on a non-plot layer, which is not critical for our purposes because when we bring that surface in the next, after this next step, we'll actually look at how that behaves in our drawing. Okay, so going back to our survey, we've taken the existing grade out and saved it into our data reference DWG folder, and now it's available for all drawings to be data shortcutted in. So now we're done with these contours here. So I'm going to select a major and a minor contour, hit select similar. and then just isolate them through the right-click menu, isolate objects, hide selected objects. I just want them to go away for now. If I were to close this drawing and then open it back up, even if I saved it, all isolated objects would come back to life. They would show up again. And if you ever want to get them again, if you ever want to unisolate objects that you've isolated, this is the icon to look for down here on the bottom of the screen, where we would need to go and hit end object isolation to bring those contours back. So the next task for us is to create a 2D line work existing drawing for use for later purposes. Now this isn't going to be a data shortcut drawing, it's going to be an XREF. So we need to look carefully at the objects, the object types, and the colors and layers that are being used to develop this 2D line work. So I noticed for one that we had this cyan line that looks sort of like a boundary, and it says in our layers list that it's called easements. Note that, guys, here that this is a little bit of bad CAD going on with the surveyor. Again, he's not using Civil 3D, but he's got a layer called easements that has a color associated with it, but he's overridden that color with the color cyan. Be mindful of this because we're going to have to make changes to that as we go forward. Really, a lot of today is sort of building towards learning how to print and learning some things about printing from CAD, like color use. And when working with surveys, that becomes pretty critical. So we also notice a layer here of grid work that looks like it may have been used to create surfaces in his own program, but this is not going to be pertinent to our 2D line work drawing. So I'm actually going to freeze that entire layer and see what happens to the drawing. To do that, I'm going to use this button off the Layers 2 toolbar, and it's called Layer Freeze. The keyboard shortcut for that is LAYFRZ. So Layer Freeze, and then I'm going to turn off that current layer and see what happens. Now, to really see what everything that was turned off, I'm going to actually undo that with Control Z. Maybe. There we go. And just make sure that I'm not turning off things that I didn't want to turn off. So again, we could turn that off, and then you could also do it here, undo. It looks like that I'm turning off things that I don't really want to turn off. There's maybe too many objects that are on that layer. So I'm going to use a different method to isolate, further isolate the objects that I want to bring into a 2D line work drawing. So I know I need data for this intake at the James River. So I'm going to go ahead and individually select objects within this area. And I'm grabbing text and line work and leaders, all kinds of stuff that the surveyor spent time creating. But what we need to realize is this surveyor is not a Schnabel employee. The surveyor has their own CAD standards and methods, and that might not fit well with our own standards and methods. And so with almost every survey, we have to take the time to make it our own, so to speak. We're not changing the XYZ of any of the data, but we are changing the colors and other and layers and other aspects of their drawing so that we can make it look good on our own drawings. So we're grabbing individual components of this survey sort of carefully and methodically, text and line work that has pertinent and important data for our needs. But we're not grabbing everything. We're grabbing most of the important stuff and then trying to. Here I inadvertently grabbed one of these red survey lines. I think these are break lines in his surfaces. But I'm going to shift and select it again to deselect it. it looks like we have a water line for the James River. That'll be important. We also have what looks like potentially a wetlands boundary. So maybe an environmental engineer or someone else went out and staked these, and the surveyor grabbed them during his surveying. So we'll grab all this stuff. It's all going to be pretty important for our needs. Again, shift select to get rid of a selection that you've already developed. So what I'm doing here, guys, is actually developing what's known as a selection set. Every time I move my cursor over a group of objects, it's selecting those objects and adding to my selection set. We have another piece of that water line here, and then an edge of road here, and some more text. It looks like we've gotten most everything that we need out of this survey. And so I'm going to right click and add that to the clipboard by hitting copy. I just want to make sure I've got pretty much everything we need. We can always come back and add to that selection set if we need to. But for now, this looks pretty good. No, I decided I don't want that one, so I think we're good. That may be a boundary line. We may need it. So we'll add all of that to the clipboard, and then we're going to open up the detailed DWG template. Because this is all 2D line work. We're not putting in any surface data or anything that's needed to create alignments or anything like that. So the detailed DWG is the proper template for this next step. Everybody hanging in there okay, guys? All right. So now that this is open, it opens up in a model space. We've got the truncated layer list associated with our detailed DWG. I'm going to right-click, clipboard, paste to original coordinates, and we'll take a look at this stuff. For now, because I just really wanted to get the data somewhere that I could save it in the proper place, I'm not going to make any changes to layers and colors. There will be a lot of changes to this base file with time, but for right now, I just want to sort of get it out of the survey and save it into our own template, and with an idea that I will make changes to it later. So I will save as, and we're not going to save it under data reference DWG, but we will be saving it in the base drawings existing folder. And I'll call this 2D LW for 2D line work existing. Okay, now that that's saved, I'll go and close it off. And, you know, honestly, we're pretty much done with this survey. The only thing that I would want to come in and note, and this is important to do pretty early on after you've gotten the survey, and not all surveyors will have this information in as text in their survey, so you may need to call them and talk to them about it. But almost every project will have some form of notes at the beginning of the project set that will include where the surveyor, what surveyor performed the survey, what date they performed the survey, and what vertical and horizontal datums were used in generating that survey. So I always look for that information. If I can't find it right off on their survey itself, I may want to reach out. I may want to look through the archives as received folder and see if there's other correspondences that were saved there that has that information for me, or reach out to the surveyor themselves, call their office or call their cell phone and see if I can't get some of that data. It's basically origination. Excuse me. It's basically origination data. Where did this data come from? Who can someone call if they want to verify that that data exists outside of Schnabel's servers? So we're pretty much done with this, and I'll go and close this survey. Again, I'm not going to save it. That needs to stay archived exactly how it was received with no changes. I do want to point out one other thing. This is another survey that we got, and like a lot of surveys that we receive, it was generated in a program that was not Civil 3D 2016. In fact, you know, you may get warnings when you open up a surveyor's drawing saying, hey, this DWG was created in a program not licensed by Autodesk. Do you sure you want to open it? Oftentimes you'll just say yes and roll with it, but I do want to point out this. This survey in particular When we click on one of the contours and look at the properties, it comes up as a very odd term. It calls it an ACAD proxy entity. Um, this is pretty common for somebody that uses like a Carlson survey or some other older form of surveying software that they interface with CAD but don't necessarily create a one-to-one in terms of the object types. And so when you see this in a survey, what you should probably do is experiment. And the easiest thing to do is to actually explode the object. And so individually, I'm just going to select this one contour and hit the explode button over here, and then see what we get when we're done. So now, when we explode that ACAD, again, it was an ACAD proxy entity, we see that we got a piece of M text from it for the contour label and a tiny little segment of a polyline. But if we were to select similar, we would get the entire segment of the polyline of that contour as individual polyline elements. There's 180 total in that one short piece of survey line work. This is just, you can use that to create a surface. Having that little gap there is no big deal. So, just letting you know that sometimes you'll run into object types that you're not familiar with and that you can't necessarily build a surface with, but they're out there. So just be mindful of that. I wanted to show you that with that particular survey, so you can be aware of it when you come across it. Again, this is a survey that's archived and as received. I'm not going to save it. But now we're going to make some use of the two different pieces of the survey that we generated in this first task this morning. So I've got a Civil 3D template drawing open. I'm going to switch over to model space. And the first thing I'll do is actually bring in the XREF for the 2D line work here through my XREF manager. I'll click on Attach DWG and navigate to that folder. Again, we're in base drawings existing, and there's our 2D line work existing that we just created. I'll hit open, again, making sure that the defaults of overlay, one X and Y Z scale of 1 with uniform scale, and that the insertion point is always 0, 0 with an angle of 0. Click OK, and then zoom extents by double clicking on my mouse wheel to zoom to that area. The next step is to scroll down to the bottom of the prospector and expand surfaces. When I right click here on EG, I'm going to ask it to create a reference. Here we're going onto our own surface layer here called CTopo EG. The name of the surface is EG. We're going to leave all of this alone. Contours 2 and 10 existing is fine. I'll hit OK, and there's our surface. Okay. Everybody following along pretty well here and everywhere else? I'm hoping everybody's doing good. We're going to take a quick look at how this would be developed for someone to look at and review. In other words, we're, as I said earlier, we're building towards printing this for someone to look at. So there's a few more steps before we're actually ready to print and or make changes to get it ready to print. So one thing we're going to need is a title block. Now we keep a library of title blocks and other reference objects on our server on the K drive. So I'm going to navigate to there very quickly and go and pick out a 22 by 34 title block. So I'm going to go under Library, General, Title Blocks, and I'll grab the 22 by 34 and hit open. Okay, I'm going to delete the north arrow out of here, and I will go ahead and make some changes to the title block information. I'm not 100% sure what all this information is going to be, but I can change it later, so I'm not that worried about it. But I'll go ahead and put the project name in here, Tenasca Sediment Removal. I'm not 100% sure what this information is going to be, but I do know it's in Virginia. For now, I'll just put James River, Virginia. We'll later fill out the information for the project engineer and the project engineer's state number. But for now, I need to save this in the project folder. So, File, Save As, and we'll go back to the 2017 projects folder. Now, our title blocks are also saved under Drawings, Base Drawings, Border. And I'll put the project name at the end of this title block name, 22 by 34 Tenasca. I'll save that there and go and close this. Now this drawing that we brought our other data into, I'll switch over to my paper space and then import that newly created 22 by 34 title block. Attach DWG, and we'll go back up to Base Drawings, Border, and insert the 22 by 34 title block. Same as yesterday, it comes in with a units issue. We'll scale that by 12. And it fits perfectly in our space here. All right. Next thing is to create our viewport. So I'll go and switch to the depth points layer and then use the mview command to create my viewport. So the drawing automatically zooms to extents for your for whatever objects are in your model space. I probably don't need to show this whole piece of the road. I'm really focused over here. So we're going to try and find both a rotation and a scale that is appropriate for this drawing. So we have the James River up here, and I believe that we're flowing from west to east. So I will likely create a user coordinate system based on that rotation, but I'll further refine that rotation. But if we remember from yesterday, one of the first steps was to create my own little dummy north arrow somewhere in the drawing so that I could keep myself oriented. So the good thing about this is I have actually some reference geometry here to use to snap to on my UCS command. So I'm going to use this intake line work to develop my user coordinate system. So again, from yesterday, we're going to type in UCS and then enter. And then I'm going to use this endpoint here and here to develop my user coordinate system. And then right click to finish the command. And we see that our cursor has updated to that new user coordinate system. And then I'll type in plan to execute the plan command and then hit enter. Uh-oh. Oh, this is a very interesting error, guys. Can anybody tell me what happened here? Why does our surface look like this?
It started drawing all the triangles and circles.
Yeah, but why? Does anybody know why?
Change the style.
No, so what's going on here? This is a great error to show you. So this is what a surface looks like when you look at it in 3D. It's hard to tell what's going on right now. So along with, when I created that UCS, I did not realize the surveyor had this line for that 2D line work at two different elevations. And so inadvertently, I ended up creating a UCS based on a non-planar view. So we're not looking at this from straight up and down right now. And that's why we have this triangulated view of the surface itself. Okay? So that's an interesting error and one that we're going to correct right now by drawing over this line with our own polyline, moving it slightly off so that we don't have any, the ability to click on the wrong endpoint there. And then we're going to investigate this. So see what we have here. Current vertex, this first one on the left, is at elevation negative 1,135.7457. Very interesting. When we look at elevation 2, it's putting them both at one of those elevations, at that same elevation. I'm going to take the entire polyline that I've just generated back down to elevation 0, and then I'm going to redo my UCS command based on that new flat polyline. Now when I type in plan, current UCS, oh, it's still giving me an error. Huh. All right, let's start from the beginning here, guys. Let's go plan, world, and then I'm actually going to redo the UCS command and reset it to the world UCS. And I want to just double check. This is at 0, and we're going to redo the UCS again. Being very careful that I select the right points here. Okay, let's try this again. Huh. Well, this is a mystery to me, and I'm not sure why it's doing this. So we're going to not rotate the UCS on this particular drawing because it's being so problematic. You know, if we were in a class sitting here, I would spend the next half hour, an hour trying to investigate why this is happening, what I'm doing wrong to make it happen. And I will try one more time by not clicking on any objects at all, but just sort of defining my UCS loosely based on data out here and see what happens. Okay. So there we just had a clear real-world example of the dangers of object snap and what can happen if you don't know what you're clicking on. So it's always great to get funny errors like that in a live class. So we're going to rotate our north arrow to be representative of what we're showing here. We're going to make sure that we get most of the data, most of the survey data in this view, and then sort of experiment with different view scales to see what's going to work best for this. You know, I think 1 to 20 is probably going to be pretty good. We may need to zoom out at some point to look at a bigger area. But for right now, this is going to be just fine. I'm going to go ahead and lock this viewport. And we need to save the drawing. So we're still here, drawing 1, file, save as. Now, again, I mentioned that we're going to talk about data management and other things as we go along. So this is a drawing that has a title block. It's comprised of base drawings, both a data reference DWG surface drawing and a 2D line work XREF drawing. But it itself is not a base drawing. Because it has a title block, and even though we're really maybe only showing it to the project manager at this point, it's not going to live in any of these other folders. It could technically live in reports if it's part of a report figure or something like that. But right now, I'm going to save it into Final Design, and I'm going to call it Existing. So it will be saved as existing.dwg in the final 05 Final Design folder. Okay? Now the next thing I want to do is get a preview of how this drawing would plot. So I'm going to simply go into the Page Setup Manager by right-clicking on the Layout tab. If for some reason you can't find your Layout tabs, there's often an option down here at the bottom to display your Layout tabs. Sometimes new versions, when you first start up CAD, it won't. These model and layout tabs aren't there. But we're going to right-click and go to Page Setup Manager, and I'll click Modify. I'd like most everybody to use the built-in DWG to PDF converter when they're trying to generate PDFs, and that's right here. So it's called DWG to PDF.pc3. PC3 is one of the printer definition files that CAD creates to be able to print to different types of plotters and copiers and whatnot. I want to point out to everybody that our plot style is called SE10.CTB. It's a color-dependent plot style. We're going to leave the defaults here for the ANSI Foley D, and we're going to leave the window and center of the plot defaults that are already set up in this template, and all of this alone. All right? We'll hit OK and close, And now what I want to do is actually do a plot preview and take a look at how that surveyor's line work and surface is going to look in our drawing. So we can tell right away that we've got some colors here, some choices that the surveyor made in CAD that aren't necessarily agreeing with our own CAD standards. Now there's occasion that we will use colors in our drawings. Occasionally big bold red colors like this when we're doing as-built drawings or red lines, and we'll show the record drawings with some red and things like that on them. There are other occasions, especially cases, where we use a lot of colors in our drawings. But that isn't our standard. For the most part, we try to stick in black and white and gray scales. And so what we'll end up doing now, or actually after a brief break, we're going to take a break here in just a minute, give everybody about 3 to 5 minutes to stretch their legs and go to the bathroom if they need to. And when we come back, we're going to be looking at refining that 2D line work to get rid of colors and to maybe make some different color decisions so that we can determine that this thing looks as best as we can. All right, everybody. So let's. It's 9:54 right now. We'll go ahead and meet back exactly at 10 a.m. That's 6 minutes, giving everybody enough time to do what they need to do and come back. Thank you, everybody. We'll be right back.